Good morning, good afternoon, everyone. Welcome to Avi Network's Takeoff Tuesdays webinars. Today's topic is microservices-based applications need distributed micro ADCs. Today's main speaker is Balaji Nagarajan, and my name is Ashish Shah, and I'll be your host. This webinar will be recorded, and we'll send out a recording after the webinar is over in a couple of days. Okay, let's get started. Welcome, Balaji. Welcome to the webinar. Thanks for joining us.
Thanks, Ashish, and good morning to everybody.
All right, so let's get started, Balaji. So what is microservices architecture, and why is everyone talking about it?
Sure. So microservices has been a very popular style of architecting an application in the last few years, popularized more so by companies like Netflix, Guild, and Amazon and Facebook. What microservices does essentially is this is an architectural style in approaching to develop an application where instead of building one big, gigantic, monolithic application, you break it down into a suite of smaller services where each service can be running as an independent process, and each service talk to every other service using a very, very lightweight protocol that typically runs on top of HTTP. What this gives us from both an application perspective is that it gives you a sense of a decentralized governance, and where you have each individual service making its own decision based on some set of criteria defined by either by business or by technology. So you have services that are defined by typically what's called as a function, where you can say, for example, if you take a classic example of a storefront, you can have a service that is a ordering system or a service that is a recommendation service and so on. So you can break down all of these into individual services. All of these talk on top of a very lightweight REST API gateway.
I see. Okay, so that's interesting. So looks like leading edge companies are moving to a microservices-based architecture. Yes. What are some of the advantages of this approach versus the legacy approach?
So few advantages are of going down the path of microservices that since it's broken down into a suite of services, each service can be developed and deployed and maintained independently of any other service. And they are typically very, very easy to write because you can write each service in a different programming language, whatever that suits the business need of that particular service. So you don't need to have a one size fits all kind of a rule when you are either developing or even deploying these services. Each service can have its own set of CPU and memory requirements. You don't need to have one big server try to run all the service on top of that. You can break it down into whatever that makes sense for that particular service.
Sounds good, Balaji. Can you give me a real-world example of one of such applications which have transitioned from a monolithic application architecture to a microservices-based architecture?
Sure. In the olden days, when typically people were developing applications, they would package it into one big Tomcat. If you take a Tomcat as your web server, it will be a one big WAR file where you have individual components that are doing a particular function. For example, you have a component that acts as a UI storefront, which would talk to a catalog service component, an order management system component, and a customer service component. All of these in turn would talk to a database where it would feed in either a product data or read from a product data or an ordering system or a customer data. When you break this down into a microservice, if you look at the picture on the right, here we have broken down the UI itself into multiple building blocks where you have a dedicated UI for catalog, a dedicated UI for checkout, order, and account management. Each of these UI in turn talks to a bunch of dependent services. For example,
I see.
A UI can talk to a catalog service to pull out the list of catalog it has right now. Can talk to a user looking at the catalog, can look at a review service to see how other users of a particular product have reviewed or recommended a particular product. And they can place an order through the ordering service, and they can go off to the customer service from the checkout and order management UI. So this is how you would have a traditional monolithic application broken down into a bunch of microservices.
Sounds good, Balaji. So as these microservices-based applications are deployed, you still need to provide them high availability, security, and scalability services. The typical application delivery functions. How have the ADCs or application delivery controllers kept up with the new model?
So that's a good question, Ashish. So one thing that we have seen in this particular segment of market is the traditional ADCs have always worked well when you have a monolithic applications where you have one gigantic application serving a bunch of traffic and you have one dedicated ADC, typically a hardware appliance, serving that particular monolithic application or two of those applications. But as these monolithic applications scale, what the users have seen is that you need to have your ADCs horizontally scaling as well. When you talk about horizontal scaling, is you replicate the number of monolithic applications and you replicate the number of load balancers.
Right.
Meaning if I have two applications, I need to have one more of your hardware appliance. But when you talk about a loosely coupled or a broken down monolithic application, it's still not microservices yet, but you have defined boundaries between, which is not exactly fitting into one monolithic application, which is why traditional ADC vendors started going down the path of a virtual ADC.
Mm-hmm.
But the difference between a hardware and a virtual is just the fact that it's virtual, meaning you have the same software ported on top of a virtual environment.
I see.
But you still have the same issues where you have to scale horizontally instead of scaling vertically. But when you go down the path of using a microservice, what we at Avi Networks have done is that we have a truly distributed network services for our architecture, where we would closely mirror the microservice deployment, where we would have our distributed microservices placed closely with the microservices of your application, and we would be able to scale better in that sense.
Sounds good. That makes sense. So can you share a little bit on why doesn't a legacy ADC solution cut it anymore? What are the challenges that you see?
Okay, the first thing is it's too expensive, meaning the fact that I need to replicate every time my monolithic application grows, I need to buy one more hardware ADC with it, means you have a 1:1 relationship between an application and an ADC. It just doesn't cut it because as the growth of an application exceeds your demand, you need to scroll more, right? So you need to have that many number of ADCs. It's just too expensive an option. And the next thing that we've seen is as the growth of mobile application has grown and as everybody has a smartphone nowadays, so your user traffic is coming in from variety number of sources. Earlier, typically users came in only from a desktop, right, sitting in an office. But now if people are browsing on their phones, on their tablets. So the microservices or your applications need to be co-located wherever the application, your user population is.
Yeah, makes
sense.
You
need to have your application either on premises or on cloud. And cloud can be distributed across the globe to reduce the latency between your user population and the response time. So given that premise, we really can't have a hardware ADC sitting in the cloud because that's just very expensive for hosting something like this. And the fact that microservices or any application now can be deployed either as a bare metal application or on top of a VM or on containers as Dockers. And when you talk about VM, you talk about either a VMware, ESXi, or OpenStack or CloudStack. So for you to get better performance, you need to have your ADC sitting along with these on the same platform as your microservices or as an application. That does not happen in case of a legacy solution where you have a traditional ADC which is running off of a hardware.
Makes sense, Balaji.
The other biggest advantage that is not provided right now by the legacy ADCs is that they don't support autonomously. They don't support autonomous and elastic scale. Whereas your microservices scale, you need to have your ADCs scaling up and down along with it.
Okay, makes sense. So, but a question comes to my mind though: why can't the legacy solutions evolve to the new architecture? What prevents them from becoming the next gen ADC?
So the biggest disadvantage is that the hardware ADCs have their architecture done such a way that they are serving only one monolithic application. And when you talk about a device-centric model, which is combining control and management and data plane, there's no demarcation between your control plane and your data plane. And all the hardware ADC can do is one or a set of monolithic applications.
Right. What about virtual ADCs?
Even when you talk about virtual ADCs as a software port of the hardware appliance, while they are still a software, they are a monolithic application still controlling an entire controller and data plane, but just that they're running in a virtual environment. They're still not truly segregated yet.
I see. And how has Avi Networks solved that challenge?
What we at Avi Networks have done is that we have an architecture that truly mirrors a microservice architecture, where our solution is built on top of a distributed microservices, where our data plane travels with your microservices wherever you have it deployed.
I see. Interesting. Can you share some more light on how Avi Network solution works?
Sure. The brain of our Avi Networks CAT-P or CAT-P system is our Avi controller, where the Avi controller is our brain of our entire platform, where it does centralized policy-based control, and it has integrated analytics engine, which will pull up data from all the distributed microservices and present it in a unified fashion to the Avi UI. So the Avi service engines, these are the micro ADCs, which are co-located with each of your distributed microservices. And these are providing load balancing, acceleration, and security functions for all your applications. And they are integrated data collectors, meaning any traffic that are passing these Avi service engines, we collect heuristics data that can be used for presenting analytics engine for the entire application.
Yeah, I look forward to seeing some of that in our demo.
So the Avi UI that is built on top of the controller is a fully programmable REST API that talks to our analytics and pulls out data and presents the analytics and ADC in a dashboard. And this gives you a very unique and visualized way of managing your applications as well. So by this particular demarcation, we have a truly distributable management plane, a truly distributable control plane, and a truly distributable data plane. So you can have your management network plane deployed in one location, control plane in one, and a data plane distributed across multiple platforms.
I see. Sounds good. So, okay, we talked about how the Avi solution has been built. Can you marry that, or can you match that up with the challenges for the microservices and see how some of these components help the microservices-based application deployments?
Okay. First is with the separation of control and data plane, we can truly distribute the micro ADCs across different locations. The second thing that we've done is that with microservice affinity, we can co-locate each data plane, dedicated data plane, with that particular microservice, wherever that microservice is located, be it inside a container on a bare metal or on a VM in OpenStack or AWS or CloudStack.
I see.
And with our unique architecture where we can co-locate our distributed ADC with a microservice, we get a true isolation between tenants. This would guarantee that traffic that is seen by one tenant cannot be seen by another tenant. Gives you super high security when you talk about critical applications, and you have true isolation between tenants. And the fact that we support elastic scale means that as your demands for your microservices change, as your volume of traffic changes, and if your microservices are scaling up, we can automatically scale up along with the microservice in the same location. You don't need any fancy algorithms on the back end to do this, and we can do this automatically on our side.
And I think you're going to show some of that in our demo,
yes,
which is coming up.
And finally, we are built on top of 100% programmable and automatable REST APIs. So any customer can write their own REST APIs. We give out a rich API guide, which people can code against to get any data. And it's very easy to program against these REST APIs as well.
Sounds good. I think that's really exciting. So let's go back to the real world scenario that you started with, which was the decomposition of large storefront application into microservices architecture. Can you describe how this microservices architecture maps to an Avi deployment?
Sure. So if you look at the breakdown of the services, here we see that the controller sits on top of all of the distributed microservices and manages and controls all the distributed microservices. You have a variety of users coming in from either desktop or mobile traffic, sitting behind a microservice, a distributed microservice, Avi Service Engine, which would essentially run at a policy engine where, looking at the URI or looking at the type of user, we can direct traffic to a particular microservice, being a catalog or a checkout or an order management or account management, typically based on whatever the request is being sent to. And once that is done, we can still load balance across the east-west traffic between microservices behind a bunch of distributed Avi service engines. And as the demand for a particular microservice grows, we can automatically scale out a particular Avi service engine, which will handle more traffic seamlessly.
Sounds good. So I think the best way to actually see this in action is through a demo.
Right.
So why don't you describe what the demo environment is going to be, and then we'll switch to a live demo on our system.
Sure. What you're going to be seeing now is I'm going to show you a very minimal, simple example of a catalog-based UI, where you have a catalog UI being load balanced by two applications, and you have users hitting this catalog UI. And I'm going to show you how to look at analytics, how to look at how your microservice is performing, or to look at app response time and more interesting data like that. And then I'm going to walk you through a scenario of creating another micro ADC for an ordering UI to see how easy it is to bring up a new ADC. And we'll talk about how to scale out a particular catalog UI if in case you have more demand.
Right. Think of a Black Friday, for example.
And then we'll talk about some transaction logs and more stuff like that.
Sounds good. So let's switch to the demo system. And in the meantime, people on the webinar, if you have any questions, feel free to ask them on our question and answer panel on GoToWebinar, and we'll answer them after the demo.
So if you look at this, we have a dashboard where you have a particular application that has been running for a while. And here, by looking at the dashboard screen, you can get a lot of information on how your application is performing currently. So here we have our health score, which will give you an indication of how this particular application has been performing in the last 6 hours or through last 1 week and in history of time. And we can break down the health score into health score of a pool of applications. And we can look at what your throughput numbers are, how much traffic is being sent, how happy are the customers who are hitting your particular application. Is there any errors? What's the request per second? How satisfied are they? So that is the health score is a measure of all these data. So when you talk about logs, so here we have a very robust logging engine where we can break down a particular transaction into a bunch of information, where we can see how a particular client's user experience is when he hits a particular microservice.
I see.
Right. For example, this particular traffic came in from a Windows machine browsing on an IE. Mm-hmm. I don't know why, but
it's a good question.
This was the URI that was requested was for a catalog UI, and the request was hit for clearance. He's looking at what type of clearances are there on your particular website.
Okay.
And the response time was near zero. The server RTT was 1 millisecond. The total duration of this traffic was 5 seconds because you have a 5 meg download of data.
I see.
So we can look something similar to that, and we can keep going something like this. So, and what you can also do is once you have a frequent set of searches you do, you can can save those searches. You can see who's all coming in from an iPhone. What are their browsing experience look like? On average, what's their response time look like?
I see. So you can figure out what experience is for a particular type of mobile users. Yes. And if you have an app developers who are trying to optimize the application for a certain type of users, you get clear information on what's going on.
Yes. So based on these data, you can see how your microservice is performing as well. So once you have some indication here, you can understand how to throw in more resources or scale up and scale down.
I see.
Speaking of scaling, when you talk about a situation where you have traffic coming in and you anticipate more traffic to come in, let's say a Black Friday scenario, you can quickly scale out your Avi service engine so that it can handle multiple a bigger load of customer coming in.
Right. So in this case, normally you would tie it to some kind of a traffic pattern. Yes. Or some kind of a resource utilization and so on.
Right. So once you hit scale out, you would see that the same application is being handled by a bunch of service engines where your capacity is essentially multiplied.
I see. Okay.
So each service engine would act to take in almost the same amount as one guy is doing. You can mirror it on multiple service engines.
Okay, so I think there was some discussion. There was an article that was published recently around load balancing for Black Friday or a Cyber Monday environment, and so I guess this kind of system is perfect for that, right? Where you can tie into either a time of a day or the amount of load that's coming in or type of users, and automatically scale out and scale in your infrastructure on demand without over provisioning your hardware ADCs.
Right, and that was one of the biggest disadvantage of a hardware ADC is because of the fact that your traffic spike happens for 3 days a year. You need to have 30% of your ADCs dedicated, not being used for the entire year. You don't need to do anything like that with us, where we can automatically scale up based on thresholds that the customers or users can set. All these thresholds are fully programmable, where I can say that even if I hit 70% of my current usage, automatically scale up to multiple service engines, and you have your load automatically coming down on each service engine. So you don't need to go down the path of having ADCs that are not being used for most of your year.
Right. While we are talking, some of the questions that have come across from the audience, so let's address those. How is Avi different from or better than virtual ADCs? I think you touched upon some of that point a couple of minutes ago, but can you share how this is really different from a virtual ADC?
So when you talk about a virtual ADC, it's a direct software port of whatever runs on a hardware. Let's try to make it run into a virtual machine to make it more appealing. Sadly, it's not appealing because of the fact that you still have to manage and control these virtual ADCs as individual ADCs, and you're not essentially making your experience any better. You've distributed the control and management across from one ADC into 10 ADCs, but you still are controlling and managing them individually.
I see. So it's really still it's still really a same as the traditional appliance model that you're going after.
Right.
Okay. All right. So at this point you're creating a new micro ADC for your ordering service.
Where.
All right. And you're typing in so here, this is the VIP that you can.
This is the VIP. So we have the ability to, if you enter either a name or a DNS or an address, we would go pull out the DNS record for that particular name.
Okay.
And you can do that for servers as well. So where you can say, it will automatically pull out the address.
Okay.
All I have to do is add servers.
And you could do that from a network as well, right?
Right. I will show that in a minute, where we can add servers by network. So one of the unique things that we have done at Avi Networks is we are tightly coupled with your virtual platform wherever you're deployed. For example, in this case, it's a VMware environment.
Uh-huh.
So once we are tightly coupled with VMware environment, we have the ability to go down and look at a VMware object to see what objects you have in your virtual infrastructure, what networks you have, how are your backend applications placed on these networks, so that when we create a service engine on for that backend application, we are sitting as close to the backend application as possible so that you don't have the unnecessary tromboning of packets back and forth in your environment.
I see. So you're optimizing the location of these ADCs based on the integration with the virtual infrastructure.
So for example, if I say for this network, show me all the servers that are existing in your environment, I pull out all the application servers that are there, I click on them, I can add it.
I see. Makes sense. Okay. All right. So let's continue our.
So that's it. So now you have a brand new application that is going to be load balanced between two servers.
I see. Okay. All right. So, and at this point, what is happening? Can you explain why?
So what is happening is that right now we are waiting to create a service engine. We're going to create a service engine which has interfaces in both the front end and the back end pool segments.
I see.
And once it's that is done, your VS is going to be up and running.
I see. Okay. All right. So while we do that, can you can we go back to the to our catalog UI, and we were also going to talk about doing the scale out.
Right. Let's try that now. So once I hit scale out, I'm automatically provisioning another SC to handle any traffic that's going to come to this particular VS.
I see.
So right now it's being load balanced by one distributed microservice. It's going to be now done by two.
Okay. All right. Sounds good. So while that is happening, there are some more questions that are coming in from our panel, which is great. So one question is, what are the elements that make up the health score? It is just total, and is it tier-based latency? So can you explain how the health score is made up?
Sure. I can quickly go down and show you how a health score is built. So for example, a health score is a combination of a performance score, any penalties, resource penalties, or anomaly penalties, or security penalties. All these combination makes up a health score of an application. So when you talk about performance, we can look at connection apdex. How does a page load time look like for a end user's browser experience? What is the response apdex? And what is a pools? How are your backend pool applications behaving? And the good thing about our CAT-P solution is that all of these are customizable. So we're not going to say that just because my numbers look good here, this is what it should look like in any other virtual infrastructure. So if you go down to look at templates, I can specify that in my environment, I'm okay to have a satisfaction threshold of 6 seconds or 5 seconds based on how historically my applications have responded. So all of these numbers are entirely configurable.
I see. Okay, so it's a very customizable, flexible system. Okay. The another question that has come up is, what is the instantiation of each service engine? Is it how is the service engine created? So in this case, we're using a VMware infrastructure.
So in this case, it's a VMware environment where the controller automatically spins up a Avi service engine virtual machine, and that is spun up to be as close to your backend application as possible, so that we avoid the latency of service engine to backend traffic.
Right, and it could also be a container if you want.
It can be a container. Okay. The current what we support right now is we can run inside a Docker, we can run on top of CloudStack, we can run on top of OpenStack and AWS.
And in addition to the VMware environment.
In addition to the VMware environment.
Okay. So one more question that has come in is, okay, if I have a a legacy ADC, whether it's a hardware ADC, if I go towards the microservices-based deployment, what are some of the challenges that I'm going to see upfront?
So in the case of a legacy ADC, they are deployed at the aggregation layer of the network. So that becomes a choke point for the traffic. So as the microservice-based application has more east-west traffic, you cannot afford to have your hardware ADC sitting at the aggregation layer. So that's the suboptimal placement of this ADC results in a lot of traffic tromboning back and forth when you try to serve one particular request. This is one of the reasons why we went down the path of having a distributed microservice architecture where we place our service engine close to the backend application so that we are essentially removing one back and forth traffic when we need to get a resource from a backend application.
I see. Okay, makes sense. All right, so let's continue with our demo and see what has happened on the service engine
So
side.
right now, the scale out is done. Now, as you see that a particular virtual service is now being served by 2 service engines, and now this virtual service is now will be able to handle double the capacity of what it was doing.
I see. So you were able to do that. So here we did a manual scale out, but just clicking scale out.
In a production environment, what you will be able to do is you'll be able to set thresholds saying that if my traffic ever increases beyond 70% of capacity of a service engine, automatically scale it up.
I see. Okay.
And that is applied on a group of virtual services or on a single virtual service.
Okay. And while we were talking, looks like our ordering system is also been
Up and running.
running. So at this point, it's ready to accept traffic.
Yes.
Excellent. I think that was a great demo. So let's go back to our presentation and summarize the environment.
So in this webinar, we saw how Avi's microservice architecture is optimized for the next gen microservice-based AP apps. So we provide multiple services in a single virtual service. We can do L4, layer 4, layer 7, be it HTTP or HTTPS, and we support a myriad of HTTPS certs. And we have a very, very robust analytics engine, which is fully programmable, and it's very easy to write your own REST APIs to gather data on how your virtual services is behaving, how your backend applications are behaving, how individual backend applications are behaving in your virtual infrastructure.
All right, sounds good. Thanks for that, Balaji. So if somebody's interested in the next steps, you can go ahead and download the white paper on load balancing microservices-based apps. It's on our resources site. So go ahead and do that. It will have more detailed version of what you heard on the webinar. You have also 2 ways in which you can interact hands-on with our system. Go to our website and you can start your free trial. You will have immediate access to both a VMware environment as well as an OpenStack-based environment software that you can download in your labs. Or you can try our interactive sandbox at tryavi.com, where you'll have access to a preset Avi environment, and you can have a couple of applications that you can play with. Follow us on Twitter at Avi Networks, and if you have any questions, do reach us. We can be reached at info@avinetworks.com. If you have questions around our product or need a live demo, reach us at sales@avinetworks.com. Thank you.